Hi, it's Maravillogia, and today's video is about the stars, what they are like and how we can see them in the sky. What are stars like? A primary school student knows that there are celestial bodies that emit light, in contrast with other celestial bodies like planets. Here you are watching a video of the sun, a star. You see it rotating and check that the whole sphere emits light. Compare it with this other video of the Earth, a planet. When rotating, only half of the Earth is illuminated, only the half that is facing the sun. So, Earth doesn't emit light, but reflects sunlight. In short, stars emit light and planets don't. If you see a planet, it's because it is reflecting light coming from a star. Let's go deeper into the phenomenon of light. This is Michael Jordan in a lighted room. We see him because he reflects the light from the room lamps. Would we see him in a dark room? No. Michael Jordan doesn't emit light. He's just a star in the metaphorical sense. However, if observing him with an infrared camera in that dark room, we would see this. He doesn't emit light, but he emits other type of radiation, infrared radiation, the type of radiation emitted, among others, by bodies that are at 36 degrees Celsius. You have to remember that all bodies emit radiation, and the type of radiation they emit depends on the temperature. Light is a type of radiation different from infrared. It is visible radiation, only emitted by bodies at a high temperature. In short, stars emit light because they are very hot, much hotter than humans. This brings us to the next question. Why are stars so hot? Russian physicist George Gamow was the first to know it. The second was his girlfriend. He wanted to share this moment with her before sharing it with the scientists. Romantic, isn't it? He discovered that the stars are at such a high temperature because nuclear fusion reactions occur there. For you to have an idea about what is a nuclear fusion reaction, we are going to compare it with chemical reactions. A typical chemical reaction is what you see here. This is a drawing of two hydrogen atoms. Both atoms react, sharing electrons and forming H2, a molecule with two hydrogen atoms. Meanwhile they are part of the molecule, they both continue to be themselves, and they may separate and become single atoms again. None of that happens in nuclear fusion reactions. Hydrogen atoms fuse, merge, stop being hydrogen atoms, and become helium atoms. A new type of atom has been created. This is how the atoms of the universe have been originated. The atoms we are made of were created in a star. We are stardust, but this will be the topic for another video. I hope you have understood how different are both types of reactions. But for now, I haven't told you the most important difference, the amount of energy obtained in both. First one releases 400 kilojoules per mole. If you don't know what a kilojoule per mole is, don't worry, but stay with the fact that the reaction releases around 400 units of energy. The second one releases much more energy. You guess? Hydrogen fusion to form helium releases 4 times to the power of 11, about 1 billion times more energy. Now you'll understand why stars are so hot. Those nuclear fusion reactions cause stars to be at a very high temperature, hot enough for stars emitting light, visible radiation. As you know, visible light comes in different color. What about the stars? Do they have colors? The answer is yes. Not only that, star temperature can be deduced from the color of a star. You may not know it, but your hot and cold water tap are set incorrectly, because I suppose your cold water tap is marked in blue and the hot one in red. It is just the other way around. I'll prove it with the following example. The flame of this kitchen burner is blue in the gas outlet part, the hottest. As the flame moves away from the gas outlet, it becomes more yellow, and at the edge, the coldest part is reddish. You may wonder why in our culture red is associated with heat and blue with cold. I don't know. It may be because things that emit red light are much hotter than those that don't emit light. For example, this red lava is hotter than the black rock. However, if blue lava existed, it would be hotter than the red one. This image shows stars of different colors and temperature. Colors here are seen much better than with the naked eye, but if the stargazing conditions are good, you can glimpse the color of the stars. You'll notice that the star with the highest temperature, Rael, is blue, and the coldest one, Antares, is red. Our sun is in the middle, that's why it's yellow. How do stars move? We can start observing stars during the day, because you already know that the sun is a star. If we were looking at the sky for 2 days, we would see what is seen here in a few seconds. Not only does the sun move throughout the day, but so do the stars at night. However, are those movements real? Stars are moving, all of them, all the time. But the real movement of stars is not apparent from Earth over a human lifetime. They are too far away. The following example may help you to understand it. You know that cars travel at a lower speed than planes. At the same time, you'll have noticed how a car near you passes a lot faster than a plane in the sky. What will happen to stars? Well, if a plane seen 50 kilometers away apparently moves slowly, imagine what will happen to a star that is trillions of kilometers away. Stars are so far away that although they move very fast, much faster than any plane, its movement is not apparent from Earth in a human lifetime. At this point you may be confused. What about the video in which we saw how the star moved throughout the night? It's time to explain apparent movements. Imagine you are on Earth watching the sunset. You would see the apparent movement of the sun, but this is not the real movement. Now we are looking at you from outside the Earth. You are in the red marker seeing what fits in the blue rectangle. As the Earth rotates, you would see the sun from different angles, until you would stop seeing it because the Earth has moved, and now you are facing a region of the space in which the sun is not. During the night, you'll observe the apparent movement of stars from Earth. The real movement is the Earth rotating, and you moving with it, and seeing different regions of the sky as the Earth rotates. Another question to address is where stars are. Stars are really far away from Earth, trillions of kilometers away. So, it's not convenient to express such a large distance in kilometers. The distance between stars is measured in light years. 1 light year is the distance that light travels in 1 year. Makes sense. To calculate the actual distance, you simply need to multiply the speed of light, 300,000 kilometers per second, by the number of seconds in a year, around 31 million seconds. In total, light travels around 9 trillion kilometers in a year, a 9 followed by 12 zeros. Huge. And this fact has important consequences. What would happen if a star were born today in a region that is a light year away? Today we wouldn't see the star, nor in a month, nor two. We would see the birth of the star a year later. Following the same reasoning, it takes 8 minutes for sunlight to reach the Earth. This means that if the sun disappeared right now, we would continue to see it for 8 minutes. So we don't see the current image of the sun, we see the image of the sun 8 minutes ago. Think about that. When you look at the sky, many of the stars you see no longer exist, and in places where you see dark areas, there may be a star shining. Well, I hope you learned and enjoyed watching this video. Thank you.